Okay, reaction of the aldehydes and ketone, that topic is still continued. And next addition next nucleophilic addition reaction of this carbonyl compound is the addition of the hydrogen cyanide. Hydrogen cyanide adds to the carbonyl group of the aldehydes and mostly ketone to form stable alpha cyanoalcohols commonly known as the cyanohydrin. The product obtained by the addition of this cyano group to the carbonyl group that is known as the cyanohydrins. And the oral reaction is as follows. Aldehyde when treated with these hydrogen cyanide, they leads to the formation of the aldehyde cyanohydrin, then ketone leads to the formation of the ketone cyanohydrin. In this case, acetaldehyde is used, so acetaldehyde cyanohydrin will be obtained, and acetone by reaction with this hydrogen cyanide will lead to the formation of the acetone cyanohydrin molecule. This hydrogen cyanide is a very poisonous gas, and it is produced in situ. In situ means that it is automatically produced by the reaction and the mixture of the action of the dilute sulfuric acid on the potassium cyanide. When these two are mixed, this hydrogen cyanide will be in the reaction mixture will be produced in situ. Ex situ and in situ, these are the two synthetic procedure methods. Mechanism involved for the addition of this hydrogen cyanide is involve the following steps. In the step 1, the formation of the nucleophile will take place, and the base removes the proton from the hydrogen cyanide to produce the cyanide ion. In the presence of the base, it means that this is a kind of the base catalyzed reaction, and base will abstract the proton from this hydrogen cyanide, and a cyanide nucleophile will be generated. In the step 2, attack of the cyanide ion on the carbonyl carbon, and this cyanide ion, negative cyanide ion, will attack on the positively charged partial positively charged carbon of the carbonyl group and will lead to the this intermediate structure. This electron density will be actually shifted towards oxygen by the attack of this cyanide ion on the positive carbon, and this intermediate structure will be produced. In the third step, addition of the proton give the final product, and the proton of the solvent, usually the water, combined with the anion to give cyanohydrin, and the proton that will be accepted by this negative oxygen of this intermediate and leads to the formation of the cyanohydrin. Importance of these cyanohydrins are as they are used for intermediate in the organic synthesis because they are easily converted to the alpha hydroxy acids or to the beta unsaturated acid on the acid hydrolysis. So these cyanohydrins can lead to the formation of the different kinds of the alpha and beta hydroxy acid. Alpha hydroxy butyric acid and beta butanoic acid are produced by these reactions, cyanohydrin reactions. Okay, the another addition reaction is the addition of nucleophilic addition of the bisulfite. Aldehyde and ketone react with a concentrated aqueous solution of the sodium bisulfite to give solid adducts, which are essentially sodium salt of the alpha hydroxy sulfonic acid. These carbonyl compound, when treated with the sodium bisulfides molecule, these lead to the formation of this alpha hydroxy sulfonic acid, which are actually the sodium salt of the alpha hydroxy sulfonic acid molecule. And these are the some example of the aldehyde and ketone giving rise to these alpha hydroxy sodium salt of these alpha hydroxy sulfonic acids molecule. The bisulfite addition product of the carbonyl compound are crystalline salts soluble in water but insoluble in the organic solvent. The mechanism of the addition of this bisulfite into the carbonyl involves the following steps. In the step 1, the reaction involves a nucleophilic attack by the sulfur atom of the bisulfite ion at the carbonyl carbon, followed by the sequence of the proton exchange with the solvent. This bisulfite ion sulfur is containing lone pair of the electron, and that will attack on this partial positive carbon of the carbonyl group and will get attached with itself. Or we can say that this is the negative side of the molecule and this is the partial positive side of the molecule. So this negative side bisulfite ion will attack on the partial positive or the nucleophilic center of the carbonyl. In the step 2, the proton exchange by the solvent take place. In this case, mostly the water is used as a solvent, and here this proton of the bisulfide ion is abstracted by this is water or the solvent molecule, and this is removed from the system as in a hydronium ion, and in turn this hydrogen will, before leaving, will give its electron density toward this SO3 molecule or SO3 part of the attached molecule, and become, this will become SO3 negative, and hydronium ion will be produced in the step 3. That hydronium ion will give a proton toward this negative oxygen, and this final adduct will be produced from this reaction. Important of the reaction is that bisulfite reaction is frequently used for the separation, purification, and identification of the different kinds of the carbonyl. Another addition reaction is the addition of the Grignard reagent to the carbonyl compound. Aldehyde and ketone react with the Grignard reagent to give an addition product which can be hydrolyzed with the dilute acid to yield an alcohol. This carbonyl group is being or attacked by a nucleophilic addition of this Grignard reagent into this carbonyl group take place, and this lead to the formation of this intermediate structure or intermediate molecule, intermediate addition product, which upon acid hydrolysis leads to the formation of the alcohol. It means that the alcohol is the most final product of this Grignard reagent to the carbonyl compound. The reaction produced a convenient way for preparing alcohol that contain higher carbon chain than the starting material. Formaldehyde react with the Grignard reagent to produce primary alcohol. Only formaldehyde is giving the primary alcohol. Other aldehyde will give the secondary alcohol, and ketones react with the Grignard to produce the tertiary alcohol. And these are the some example. A formaldehyde, when treated with this methyl magnesium iodide, a Grignard reagent, it will lead to this intermediate addition product, and this upon the hydrolysis will lead to the formation of the alcohol. Here, this is a partial negative side alkyl group, and this is the partial positive side of the molecule. Carbon is partial positive, and oxygen is partial negative. This partial negative methyl group will attack on the carbonyl, partial positive carbonyl, and this electron density will be shifted completely towards the oxygen, and this negative oxygen can in turn attach or attack this magnesium iodide positive, partial positive part of this Grignard reagent. And this intermediate structure upon hydrolysis, acid hydrolysis, will lead to the formation of an alcohol, and from the formaldehyde the primary alcohol will be produced. Other higher aldehydes, suppose acetaldehyde, by treated with this methyl magnesium iodide, will lead to the formation of this secondary alcohol or 2-propanol, and the ketones or the acetone molecule, these will lead to the formation of this tertiary alcohol molecule. Okay, another addition reaction is the reformatic reaction, and here in this reaction, and that is closely resembled to that of the Grignard reagents addition reaction with the aldehydes and ketone. And in this reaction, the aldehydes and ketone is treated with the alpha bromo ester. In the present, this alpha bromo ester is treated with this carbonyl group in the presence of this zinc metal in the and usually in the solvent benzene, and this initially form addition product on hydrolysis will leads the beta hydroxy esters molecule, and mostly the organic zinc reagent, that this organic zinc reagent is appeared to form as an intermediate, and which actually adds to the carbonyl group of the aldehydes or ketones in the same manner analogous to that of the Grignard reagent. And this initial products, and this initially form addition product upon the hydrolysis, acid hydrolysis, will lead to the beta hydroxy ester molecule. Here, this is the kind of the different steps involved in the formation of this finally beta hydroxy ester molecule. The beta hydroxy esters are easily dehydrated to the alpha beta unsaturated ester, and this beta hydroxy ester that can be upon heat treatment converted to the alpha beta unsaturated esters. The mechanism involved the following step. In the step 1, the formation of the zinc salts of the enol esters. These are formed. This is the alpha bromo ester molecule, and then when they are treated with the zinc by metal by nature, they are electrophiles, and it will show attraction towards the electron here. When zinc is being attacked or being attracted by this oxygen atom, oxygen will shift its electron density between these two carbon, and here this bromide ion will be get attached with this positively charged zinc. This is the positive part of the molecule forming enol molecule, and this is actually the negative part of this enol molecule. In the second step, the zinc salt reacts with the carbonyl compound, and if this carbonyl group is being attacked by this zinc salt intermediate enol ester, that pi electron density negatively charge of the side of the molecule will attack on this positively charged nucleophilic center of the carbonyl carbon, and this electron density will be shifted towards the oxygen, and this is the partial positive part of the molecule. It will being attracted by this negatively charged oxygen, and this intermediate structure or the zinc salts when react with these intermediate zinc organozinc intermediate or organozinc reagents are formed in this two. In the third step, acid hydrolysis of the will give the final product. This beta hydroxy esters will be formed by this organozinc reagent hydrolysis, and this is the partial positive part of the molecule. This is being replaced by the proton of the water, and here H will be added it, and this beta hydroxy esters will be produced by the acid hydrolysis. Important of this reaction is that it is a variable synthetic tool, because the beta hydroxy esters obtained in these reactions are polyfunctional compound capable of undergoing a variety of the transformation. Here in this case, hydroxyl group is there, carbonyl group is there, and also this is a kind of the ester molecule, as well as one part is showing the alcoholic properties. So a variety of transformation can be undergone by this product or these reactions.